In section 5.5 we continue to look at linear equations, but now we're going to be looking at pairs of lines or even groups of lines, and in particular we're interested in the relationship between those lines in terms of whether they might be parallel or perpendicular. And the key here is going to be slope. So to determine whether lines are parallel or perpendicular, we want to look at the slope of the lines. So as a reminder, parallel lines are lines that are in the same plane that never intersect. And we have two conditional statements here that will hold for us. If two non-vertical lines in the same plane have the same slope, then they are parallel. The converse also applies, that if you have two non-vertical lines in the same plane that are parallel, then they have the same slope. So if you're testing for parallel lines, look at the slope and see if the slope is the same for each line. If so, they're parallel. Perpendicular lines are a little more tricky. So as a reminder here, perpendicular lines are lines in the same plane that intersect to form a right angle. So they intersect at 90 degrees. If two non-vertical lines in the same plane have slopes that are negative reciprocals, then the lines are perpendicular. And if two non-vertical lines in the same plane are perpendicular, then their slopes are negative reciprocals. And we'll be looking at negative reciprocals here shortly. This is the same idea as inverse. You might remember when we've worked with fractions and dividing by fractions, we divided a fraction by multiplying by its inverse. Same idea here, reciprocal, inverse, but we need a negative. Alright, so let's look at some examples of both parallel and perpendicular lines. So in our first example, we're asked to write an equation of the line that passes through the point negative 2, 5 and is parallel to the line y equals 3x plus 5. So we start with our parallel line, y equals 3x plus 5, and we focus on the slope. And generally speaking, we really don't even care about the y-intercept. We just want to focus on the slope. So we know that the slope is going to be 3, which means a parallel line will have this form, y equals 3x plus some y-intercept b. And now we can use this point to substitute the values of x and y. So x is going to be negative 2, that will go here, and then 5 will be y, so that will take place here. So now we can write 5 is equal to 3 times the value of x, negative 2, plus b, and we want to solve for b. So simplify here, 5 is equal to negative 6 plus b. And then to undo the negative 6, move it to the other side, we want to add 6. So add 6 to each side, and on the left hand side we get 11 equals b, and now we can write our equation. So we have y equals, same slope, 3, so y equals 3x plus 11. Okay, so notice we have a different y-intercept. This line will have the same slope, but it's been moved up because it has a y-intercept of 11 compared to 5. Now, if this had turned out to be the same y-intercept for some reason, so if this had worked out to also be y equals 3x plus 5, just like this, then they would actually be the same line. But generally, we hope you won't run into that. Okay, number 2, write an equation of the line that passes through 3, negative 4 and is perpendicular to the line y equals 2x minus 7. So if we focus on that equation y equals 2x minus 7, the slope of that line is 2, but we need the negative reciprocal because this is perpendicular. So our slope is equal to the negative reciprocal. So negative reciprocal, that's an r, negative reciprocal of 2. Or if you want, write that as 2 over 1. So we're going to take the inverse of that, which is 1/2, and then change the sign. Because this is positive right now, we change it to a negative. If this had been negative, we would have changed it to a positive. So they'll have opposite signs, And the original line is positive slope, so this will have a negative slope. And then instead of 2 over 1, 1 over 2. So now we know the slope is negative 1/2, and we go through the same process that we did in the first example. So substitute the value of negative 4. So we have y is equal to negative 1/2 x plus b. So substitute negative 4 in for y. And this is equal to negative 1/2. It's negative 1/2 times our x coordinate of 3 plus b. So negative 4 is equal to negative 1/2 times 3 is negative 3/2 plus b. And then we're going to undo the negative 3/2 or move that by adding 3/2. So add 3/2. Okay, and we can do this over here, for example. We're going to need a common denominator here. So negative 4 is equal to negative 8 over 2. Right? Negative 4 is the same as negative 4 over 1. We need to multiply that denominator by 2 to get a common denominator of 2. That means we also need to multiply the numerator by 2. So we have negative 8 over 2, and then negative 8 over 2 plus 3 over 2 is equal to, our denominator will be 2, and then negative 8 plus 3 will be negative 5. So our y-intercept is negative 5/2. So we have y is equal to, our slope, remember, is negative 1/2. So negative 1/2 x plus b, or in other words, minus 5/2. Okay, so this line will be perpendicular to this line, and it will go through the point 3, negative 4. Okay, number 3, write an equation of the line that passes through point A and is parallel to the given line. So we can first of all look at what are the coordinates of point A, and starting from the origin, notice the interval of 1, so we go negative 1, negative 2, negative 3, negative 4, negative 5, and then up 1. So this is at negative 5, positive 1. And then to calculate the slope, pick any 2 points on the line. So for example, this goes through the origin, and it goes through this point. And then we can look at the rise over the run. So starting here, we go up 3 units. So the rise is 3. And then we go to the left 2, which is a negative 2. So we know that our slope is equal to negative 3 over 2. So rise over run, and remember that if you have a negative in a fraction, we typically pull that out front. You could put it into the numerator or to the denominator. We typically will pull that out front. So we know that this is going to be parallel, therefore our line is going to have the same slope as the one that's already shown. So we have y equals, our slope is negative 3/2 x plus our y-intercept of b, and then again we substitute the values of x and y from this point. So we have y is equal to 1, so this is negative 3/2 times our x coordinate of negative 5 plus b. And again we have a fraction, but that's okay. So we have 1 equals, negative times a negative is a positive, so this will be a positive value. And then 3 times 5 will give us 15 over 2. And remember, if you want, you can write this as negative 5 over 1. So when we multiply the denominators, 2 times 1 gives us 2, and then plus b. Okay, so now we have a positive 15/2 that we want to move to the other side of the equation. So we subtract 15/2, which means we also subtract 15/2 from the left-hand side. Okay, so now we have 1 is equal to 2 over 2. So 2 over 2 minus 15 over 2 is going to be 2 minus 15 is negative 13 over that common denominator of 2. So we have negative 13/2 is equal to b. So then we substitute that value of b into this equation here, and we have y is equal to negative 3 halves x minus 13 halves. So if we were to form a line parallel to the one that's given but goes through this point, so it's going to look something like this. That's not too bad. If it looks something like that, it would have this form. So it would have a y-intercept of negative 13 halves, same slope of negative 3 halves. All right, number 4. Write an equation of the line that passes through negative 5, 4 and is perpendicular to the line y equals 2. So notice here we have one of those special types of lines where we don't have an x appearing in our equation. We only have the one variable. And so you might want to go back and think, what does that look like? So if we have our x-axis and our y-axis, the line y equals 2 is a horizontal line. And so it's going to be a horizontal line with a y-intercept of 2, which means that a perpendicular line is going to be vertical. And it has to go through the point negative 5, 4, which means the x-coordinate is going to have to be negative 5. And remember that for a vertical line, we always have x equals some value. So because we know it goes through the point negative 5, 4, we know that x has to be equal to negative 5. And that's all there is. Okay, number 5 are the lines y equals negative 4x plus 8 and 2x minus 8y equals 7 parallel, perpendicular, or neither. And again, focus on slope. So we have y equals negative 4x plus 8. This one is nice and simple because it's in slope-intercept form. We already know that the slope is equal to negative 4. In the second example, we can rewrite this in slope-intercept form, or in other words, solve for y. So I want to move the x term over to the other side of the equation, and we can do that by subtracting 2x. So subtract 2x from each side, and these x terms will cancel. We have, don't forget the negative sign, negative 8y is equal to, now remember you can write these in either order. It's going to be very common in slope-intercept form to see the term with x first. So as long as I keep my sign straight, remember that's a negative 2x, and then the 7 is positive, so add 7, and actually we don't even care about the y-intercept here. We just want to look at the slope. Except again, in case we end up with a problem where we actually have the same line repeated twice. But otherwise, we don't care about the y-intercept. Then to get y by itself, divide by negative 8. So we need to divide each term here by negative 8. So we have y by itself is equal to, then we have negative 2 over negative 8 will simplify to 1 over 4x, and then 7 over negative 8 will be minus 7/8. And so we have a slope of 1/4. So compare our slope of m equals negative 4 to this slope, m equals 1/4. And notice that if you take negative 4 times 1/4, you'll get negative 1, which means they are negative reciprocals. This is actually the definition of a negative reciprocal, that if you multiply the two together, you get negative 1. Because the slopes are negative reciprocals of each other, these two lines are perpendicular. Okay, so that's it for this section. Just remember slope. Parallel lines will have same slope. Perpendicular lines will have negative reciprocals for slopes. And then the exceptions, the parts you have to be careful of, are where you have a horizontal line and a vertical line. We can't really deal with slopes being negative reciprocals of each other there, or two vertical lines having the same slope, since it's undefined. But other than that, you should be looking for same slope or negative reciprocals. So good luck and enjoy.